So in this class, we are going to consider our revision of our mathematics N5 as we are to consider the full paper, which was being written on 30 July 2024, which is part of our August examinations. So we are not going to waste much time, guys, as we can see. Make sure that you go through your instructions. Okay, you're given all final answers must be rounded off to 3 decimal places, okay, so which is fine, and just make sure you answer properly, writing each and every stages that you are given, which is most important. So without wasting time, guys, let us check our first question. Question number 1, we are given on 1.1. All right, that is given the ln of y is equal to, all right, so let's see. All right, there's some part of marks here, so let me just try this. So this is the ln of y, which is equivalent to the limit as x is approaching to 0 of tan of x minus sine of x over 3x squared. And you're given to calculate the numerical value. The numerical value, is it 2, is it 3, whatever that you have there, of what? The first part of ln y. So I talked about this on the introduction of our limits and continuity, that if you're given this consideration, you're supposed to work the ln as it is, okay? That is 1.1. We are given that the ln of y, the ln is just a logarithm. Remember, this is just a logarithm, which is in the base of what? Which is in the base of e. So this is equal to the limit as we are given x is approaching to 0 there. Then we've got, just going to put this in a bracket. Then that is tan of x minus the sine of x over what? 3x squared. So this is what you are having. And what are you supposed to do? Put the value of x. If the answer is direct, then we are going to get that answer. But let's see, is it going to be direct as we expect? Substituting the value of x here in place of x, in place of x, in place of x. The tan of 0 was going to give you a 0, all this part. It was going to give you a 0, all this part, if you substitute x, which is 0. So you're going to obtain a 0 over 0. I want you to choose your calculator there. Substitute in your calculator tan of 0 minus the sine of a 0 like this. You're going to obtain a 0 already here, guys. It's a 0 there by substituting the x, which is what? Which is a 0. So what is that we know? Our L'Hospital's rule. Differentiate the numerator. Remember, you'll be having your normal limit as it is there, f of x, as x is approaching to 0 over the g of x. You substitute, you obtain 0 over. What are you going to do? You're supposed to differentiate f of x, also differentiate gx, meaning differentiate the numerator and also the denominator. So let's differentiate. That is, the ln of y is equal to the limit as x is approaching to a 0. Applying our L'Hospital's rule, differentiate tan. What is the derivative of a tan? The tan gives us a sec squared. So in a consideration that you are not understanding your derivatives, you remember your formula sheet is there as an assistance in exam. So let us just quickly check for the sake of others. If you check here under the derivatives, f of x here, this is the derivative with respect to x on this part here that failing to properly indicate here is the derivative with respect to x. So if we check, not wasting time, gonna check here the tan is corresponding what to a sec squared. So you can simply consider your formula sheet in a consideration of that nature that you do not understand your derivatives. So the tan, we saw that this is going to give us sec squared x minus the sine. Remember, sine changes to a cos, and that's a positive cos, that one. The derivative of 3x squared, drop the exponent, multiplies the 3, that was going to be 6x. Remember, it's going to be x to the exponent of 2 minus 1, which is just going to be 1. And that is same as what? Same as x. So this is what you have. Substitute again. Substitute again the x, which is, and see what is happening. Remember, this is sec squared, and we cannot have this on our calculator. So what are we going to do? We do understand that the sec of x is equivalent to the 1 over the cos of x. So if it is sec squared, I'm just going to have sec squared, and this will be what? Cos squared. So meaning to say, I can substitute this. When x is equal, I'm going to substitute like this, 1 over cos of 0 like this, squared, minus, in place of this, we put a 0 there. So it's going to be cos of 0 like that. So you're going to notice that on your calculator, this was going to give you a 1. This was going to give you a 1. And 1 minus 1 is what? That's a 0. So you're going to get a 0 there. Substitute this, you're going to obtain a 0 also in the denominator. So meaning to say, we still have to apply our L'Hospital again. Once we are getting 0 over 0, the derivative again. So you're supposed to differentiate the numerator, differentiate the denominator again. All right, so let us see what are we going to have here. So the ln of y is equal to the limit as x is approaching to 0 of what? Differentiating sec squared. Can we differentiate that? Do we have the derivative from our formula sheet? If you check, we do not have that. If you consider this part, we just have the derivative of a sec here, which will give us this part of sec x tan x. That is the only part that we have. If we are to consider this, we do not have any part that is going to give us any sec squared. So what are we going to do? Because that is not given. All right, I want you to take note of the sec squared. It's just like you are given your function of a function. Remember your derivatives from your mathematics N4. If I'm given the sine x squared like this, what does it mean? From our function of function, we can differentiate considering exponent, which is affecting the whole bracket, okay? Like this. Just ignore this. You consider the exponent there. Our exponent is what? Is 2. Remember your derivative, you drop the exponent. So you do that considering the sign that is there. So it's going to be 2, the sine of x like this. Then you subtract 1. So 2 minus 1 is what? It's 1. So this means there's no effect there. Then you're supposed to multiply it to what? The derivative of what is inside of the bracket. What is the derivative of the sine of x? That is the cos of x. So meaning you're going to have 2 sine x cos x. So a power like this can be differentiated. So in our case, we are given a sec squared, this one. Like we had here when we had cos squared x. Remember when I was substituting, I was writing like this, cos of 0 squared. What does this tell us? It tells us that the presentation of a cos squared x and the presentation of a cos x in the whole bracket raised to the power of 2 like that is simply the same. Note that cos squared x is not equal to cos x squared like this. No. These ones are not the same. This is x which is being squared, but here we are squaring the whole trig. So what does it tell you in terms of a sec squared that we are seeing here? Because we want to find its derivative. It tells us we can write it as sec of x being raised to the exponent of 2. Same sec squared. Then we differentiate, just like what I was illustrating on that sine of x squared. We are going to consider this sec squared. We ignore it for now. Let us ignore it. We consider it as a single term as it is. We differentiate as we used to know the issue of the power. So meaning to say the derivative there with respect to x is going to be what? What are we going to have? We are going to obtain, we drop the power. So that will be 2 sec of x raised to the exponent of what? 2 minus 1. 2 minus 1 is what? It's 1, guys. And that is no effect. So you just leave it like that. Then you differentiate the bracket now. Remember, you ignored the bracket and you're considering what? The power. Then you consider now what is inside of the bracket. Remember those derivatives when they say differentiate without that is how you simplify this. So you have to differentiate a sec x. And a sec, we have it from our formula sheet as we saw it, guys. All right, let me bring you back to your formula sheet so that we agree on each other. So if we check on our formula sheet, the derivative of a sec x, we have it. The sec of x is supposed to give us what? On its derivative, that is sec x tan x. Its derivative is there. So meaning to say, in place of that sec x that we are given there, we are going to substitute its derivative, which is what? The sec of x, the tan of x. So this is what you are going to obtain at the end. This is what you're going to obtain at the end, of which you can just multiply. Remember, sec and sec there is same as what? 2 sec squared x, the tan of what? The tan of x. So this is what you're going to obtain if you differentiate the sec squared. So the derivative of a sec squared is going to give us 2 sec squared x, the tan of x. We move on to the derivative now of a cos. As we can consider there, we have got cos of x. Remember, if you differentiate cos, that's a negative sine x. But already there's a negative which is there. So that negative and the negative of the derivative there will give us what? A positive. So that's going to be the positive, the sine of x. We differentiate our denominator, 6x. This is just a linear, so we are going to obtain a 6 there. All right. Remember, the derivative of ax is going to just give you a. That's a linear expression from your N3 mathematics, remember? All right. In this case, we are supposed to substitute and see what are we going to have at the end. Remember, we had a consideration where we substituted a tan when we had a tan here. When we had a tan 0, it gave us a 0, and also this one gave us a 0 this side. So by just mere looking here, it tells you that if you are to substitute, definitely, this is going to give you a 0 in place of a tan. We saw this before. This is also going to give us a 0. 0 times any number. This is 2 sec squared times this. Whatever that you're going to have, the way that you're going to simplify your sec squared, you obtain 1 or whatever. But the moment that it is multiplied by a 0, what are you going to obtain? That is going to give you a 0. So that's 0 plus 0, which is what? Which is 0 over what? This one is not a 0, it's a number which is 6. It's no longer part of this. So this time, we can write our answer to say the answer that you're obtaining there is an exactive value, which is 0 over what? Which is 0 over 6. And we do understand that 0 over 6 is same as what? It is same as 0. This is not 6 over 0. Remember, 6 over 0 is what? Infinity. But this one, it is equal to a 0. So that is what we are obtaining for the ln of what? For the ln of y. Remember, our question was asking you to simplify or to evaluate or to determine the ln of y from this limit that you're given. So as you can see, guys, if you know your derivatives, the limits, they're just nothing. They're just nothing. If you know your derivatives. So let's just try to work our derivatives as much as we can. But I think with the videos that we have on limits, this is now nothing, guys. Okay, 1.12. Let's move on. The numerical value of what? Of y this time. We got the numerical value of ln of y, but this time they want that of y. What is the value of y? Remember, I was explaining about this ln to say the ln of y as we see it is simply a logarithm which is in the base of e. So understanding that it is the logarithm that we have there in the base of e, which is equal to a 0, we can determine the value of y. Your exponents and logarithms, the relationship from your mathematics N3. You're saying y is equal to what? The base, which is e raised to the exponent of the answer, which is e to the exponent of what? Of 0. And any number to the exponent of 0 is what? That's a 1. Remember your conversion of a, b, c. Log a in base of b is equal to c. We're converting this. A is equal to b to the exponent of c. So this conversion is the one that we are using now. This is your a, this is your b, this is your c. This is your a, this is your b, this is your c, according to this. So let's go again to our revision of our N3 that can actually help as we are doing our N5. Remember, N5 is just a continuation from what we had before. 2.1 on question number 2. Determine dy dx, the derivative there. If f of x is equal to cos of x using the first principle, show all intermediate steps. Checking the question paper of February 2022, if I'm not mistaken, supposed to be Feb 2022. We had a question like that. So I'm not gonna waste much of time in this case because we talked about this. I'm seeing like there's a question that is, okay, this one. Sorry for this, guys. You see, I just thought it's just a limit. I'm seeing that here, left something here. 1.2. Determine the value or values of x for which f of x is what? Discontinuous. Remember, guys, your denominator is supposed to be equal to 0 when discontinuous. So meaning to say the sign of x automatically must be a 0 there. So within the interval of 0 to 270, what are the values of x that we are going to have if we solve? Remember, there's a trigonometric equation. There are so many answers there. From your N4, you're going to determine the reference angle, which is simply equivalent to the arc sine of 0 there, and that was going to give us 0 degrees. So with our reference angle, now we have to ask ourselves, where is it that a sine is equal to 0? Which this one, guys, from our special angles that we have, or special cases, actually the issue for special cases from our N4. When the sine is at 0 degrees, when the sine of x is equal to 0 like this one, when sine of x is equal to a 0 like that, which angles do we know that affect? We've got the angle of 0 degrees, the angle of 180 degrees, angle of 360 degrees, and so on and so on. We can even notice this from the graph of your sine. Remember, the graph of your sine is like this. This is your graph of your sine. This is at 0 degrees. This is 90 degrees, 180 degrees, 270 degrees, 360 degrees. At this point, 180, 0, 180, 360. The graph of sine will be equal to 0 in the horizontal axis. So these are the angles which correspond when sine of x is equal to what? 0. At this point, we do understand the sine of x will be 1. At this point, minus 1. So at 1, the answer was supposed to be what? 90 degrees. At minus 1, the answer was supposed to be 270 degrees. We can even notice from our graph. But as we are focusing with when the graph is here, where y is equal to 0 in the horizontal axis, which angles do we have there? 0 degrees, 180 degrees, 360 degrees. But within the interval that we are given here from 0 to 270, what therefore is going to be our values of x? Meaning to say we are going to have a 0 degrees and what? Or x can be 180 degrees. Okay, we are not going to consider 360 because it's now out of the interval up to 270. Up to 270, the values that which satisfy our condition is what? 0 and 180 degrees. So you can even use that consideration. You can even use that consideration. So when you are given the condition of a 0 there, even for a cos, you can use the same idea. Remember those are called special cases. If you check your N4 mathematics, I think they have a table that they had listed all conditions that are under special cases that you can just by looking into it, you just answer your question like you just know, okay, if sine of x is equal to 1, then I'm supposed to know that my x is supposed to be at 90 degrees. Those are special cases which happen for sine, cos. So just make sure that you go through. It can help. So like I was saying on question number 2, where we are asked to find the derivative there of y with respect to x. And this question, like I was saying, it's actually, we talked about this in our February 2022 exam, if I'm not mistaken. So just go through. But we're going to have it, the cos of x. So we're using the limits that you're given there. These are the limits that you're given as h is approaching to 0. As h is approaching to 0, this is for cos h minus 1 over h, sine h over h is 1. So meaning to say whatever that you're going to do is supposed to include these limits as a hint if you are using that. There are so many ways of differentiating these guys using first principles, but we are just going to try to involve these limits that we are given there. All right, so let's save our question aside. That is 2.1. So our f of x was given as the cosine of x, and you're supposed to find the derivative there, which is our dy dx. So what are you going to do? Remember, the derivative of y with respect to x using the first principles method is supposed to give us what? The limit as h is approaching to 0 of what? That is going to be f of x plus h minus f of x, everything over h like this. This is what we are supposed to actually have. And with our f of x, which is the cosine of x, it follows that from this, f of x plus h can be determined, where x is in place of x. Remember, it was f of x. Where x is, this time you're going to substitute x plus h, where x is here. So meaning to say it was going to be cos of x plus h. This is what you have. Considering x plus h. And in this question that we are having, or in our formula, it is stating that we are supposed to subtract these two. The f of x plus h, which is this cos x plus h. We are supposed to subtract f of x. And what is f of x? That is the cos of x. Everything over h. And looking into our trigonometry, you are going to notice that we do not have any identity which specifies on subtracting these two. Like, can we subtract cos A minus cos B? What is the identity for this? We do not have. Check, looking into our identities, we check that. Okay, I want you to see that. So that will be together on how, therefore, we expand the, remember, these are your identities. If it is cos and cos, we just have this part of the product of cos times cos. Not a condition where they are subtracting a cos to say it is cos of A on its own minus a cos of B. A cos on its own minus. We do not have that. We do not have that consideration if you check through here. We do not have that. Do not confuse with this one. This is cos A minus, it's a single part which is under a cos. Not to say cos is on its own. Another cos is on its own. We do not have. So what are we going to do since we do not have anything that tells us about separating this and this at the same time? We are going to consider the first identity here, this one, on its own. Is there any identity that we can use to expand this on its own? In terms of the cos, do we have anything related to such as cos A plus a B? Do we have such consideration? Yes, we have. This one can be expanded. Remember, from your identities, that's going to be cos of A, the cos of B, then it changes to a minus, the minus sign of A, a sign of B. So meaning to say we are going to consider this as our A and this as our B, x plus h. So simply meaning to say where A is, we are simply going to put x. Where B is, we're going to put h. Where A is, we're going to put x. Where B is, we put h. Because A represents now x. So this was going to be expanded if you check properly. So that means the derivative of y with respect to x is equal to what? Let us substitute this being expanded. So it's going to be cos x, cos h. All right. So we're going to have cos x, cos of h, minus sine of x, sine of h. So this is going to be sine of x, sine of what? Sine of h. This is where you are. You have expanded this identity, compound angle identities. The cos of x is just a single term on its own. There is no identity that you can use to expand that. So you just write it as what? minus cos x as it is, everything over h. Now, looking into this, we are supposed now to consider those limits because this is what they want you to use from the hint. They gave us that we are supposed to obtain the cos of h minus 1 over h as h is approaching to 0 is supposed to give us a 0. Remember that. So we are supposed to target that in our question. Say, how can we obtain that now? That is the question. How can we obtain this cos of h minus 1 over h? Because its limit as h is approaching to 0 is going to give us a 0. Also, how are we going to have this limit as h is approaching to 0 as we are there? A sine of h over h, which is going to give us what? A 1. How can we obtain this? Okay, if you take a consideration, all these, they are under h. They are affected by h. So meaning to say we can separate h. But if you do that, you're going to notice that h was going to be separated with this term. H was going to be separated with this term. H was going to be separated with this term. So there are 3 terms there in the numerator. By this, on these terms, if you check the first part, cos h, we're going to have cos h over h, of which you do not have that here. We have cos h minus 1 over h, not cos h over h. So this separation is going to affect you. The second part, sin h over h, we have that sin h over h here. The second part is fine, this one. What about the last part? Cos x over h. Do you have anything here about cos x over h? We do not have. So meaning to say there's something that has to be done between these two, because if we separate like that, we are not going to win. There's something that has to be done between this and this. Because this middle term is fine. The middle term, if you separate, guys, this one with h, if you check sin h over h, we have it. Sin h over h is there. It is existing. But try it, the first one and this one, we do not have it here. The last one and this one, we do not have it here. So what is it about these 2 terms? If we check properly, these 2 terms, cos of x is common. It's just like this. Take the first term, cos x, cos of h, minus the last term, which is the cos of x. If you check properly, you're going to see that these 2 are common. So we can factor out the cos of x, remaining with what? Cos of h minus 1. We factored out, so we're going to divide, so it's going to be a minus 1. So if we check now, we have this cos h minus 1, cos h minus 1. We now have that. So this is how you're going to simplify from there. So dy dx is going to be the limit as h is approaching to 0 there. So this first and last combined together is going to give us the cos of x into what? The cos of h minus 1 minus this middle term that we had before, which is the sine of x, the sine of h, everything over h. So this is where you are. So the purpose of this was for us to obtain these limits, because we are limited to this. So if you use anything else, how are you going to limit that? We can see that the cos of h minus 1 is there. So if we separate now the same way that we wanted to do previously, now we are going to win. So this will be the limit as h is approaching to 0. We separate the first part. It's going to be cos of x into the cos of h minus 1 like this over what? Over h. Minus this part also separated with h. So it's going to be the sine of x, the sine of h over what? Over h. We have those limits into consideration. Cos of h, this one. We can see it. The sine of h, this one, over h. We can see it. We can see this. We can see this. We have those equivalent. What is the equivalent of this? Cos of h minus 1 over 8. It's 0 there. So meaning to say this was going to give us a 0. The whole of this part was going to give you a 0. What about sine h over h? As h is approaching to 0, what do we have? Sine h over h as h is approaching to 0 is what? It's a 1. So meaning to say the whole of this part is going to give you a 1. So let's simplify, guys. We have introduced the limits. So we are not going to rewrite this because we have used that limit as h is approaching to 0. And here we got what? We got it's a hint that we're given. We're not worried about proving that. Use as it is. So meaning to say you're going to have the cos of x times what? Times s0 minus the sine of x times what? The whole of this part was going to give us a 1. So at the end, that's going to be what? Cos x times 0, that's 0 minus the sine of x, which is going to give us minus sine of x. So that is the derivative at the end that you're going to have. Is it that you're supposed to have when you are differentiating a cos x? Is it so that the derivative of a cos x is minus sine x? Yes, that's true. That is what you're supposed to expect to have. So these are the stages, guys, which are important to note, especially on this stage of separating here. Be very careful there because you want to have the limits that you are given. So you separate in a way that those limits can be accommodated in your simplification. You must accommodate the limits that you're given, this one. Without this, guys, it's going to be difficult. Unless you are using any other method. But if you are working with the hint, this one that you are given, there's no way we are supposed to separate in a way that you use that. 2.2. Determine dy dx in each of the following cases. Simplification not required on 2.21. Let's see what we are given there on 2.21. We are given that y is equal to the sine raised to the exponent of 6, and we've got the ln of 4x to the exponent of 5, like this, all right? So this is also a bracket. I'm just going to put it like this so that okay, let me just do it this way, a bracket like this, okay? So considering this, we can say this is simply going to be part of a function like what we had. Remember when I was differentiating this sine x squared, we considered the power, then the derivative of what is inside. This is the same thing that we are seeing here. There's a power. It's the same, guys, as we're going to write this as sine. This is going to be the ln of 4x to the exponent of 5, like this. Everything like this being raised to the exponent of 6. So you're going to drop the power first, which is this power that you're given. So the derivative there, you drop the power, 6 sine as it is, remains as it is. But we subtract 1 on the power. So 6 minus 1 is what? It's 5. This, guys, it remains. You're focusing on the power here. You're on this, the power. So everything is remaining as everything as it is. You just drop the power, you subtract 1, but everything, the sine, the ln, this part remains as it is. So it's going to be what? Into this. So it's going to be the ln as it is. That is the ln of 4x to the exponent of 5 as it is. What were you going to do if you have differentiated, if you have focused on the power like this? Remember, you're going to differentiate the sign, the sign on its own to say, what is the derivative of that sign? Remember, sign changes to a cos. Sign will change to a cos. So it will be cos of what is inside, not the power, just the cos, this one, cos of this. This, which means we've got what? The ln there. So it's going to be cos of the ln 4x raised to the power of 5, like this. Then what is it that? Because we also have a ln. The derivative of that ln, because as you're considering the sign, it is having a term inside. It is not just like x. This is a normal term. So you're supposed to find its derivative now. That will be the final case. That will be the final case. Now, the derivative of a ln. What is the derivative of a ln? How do you differentiate a ln? Remember, a ln, first derivative of f of x over f of x. So this is your f of x. here. So what is its first derivative? The derivative, you remember you drop the power there. That was going to be 20 x to the power of 4 over f of x as it is, which is 4 x to the exponent of 5. So here I'm just going to write as it is 20x to the exponent of 4 over 4x to the exponent of 5. Remember, they are saying simplification is not required. So meaning to say you can even just leave your answer like this. So it's a function of a function consideration, guys, that you just have to apply. As you can see, nothing much if you do understand the basics of your derivatives. On 2.2, again, it is another part where you're supposed to use the same consideration. That's 2.22, where we are given y is equal to x to the exponent of 2. That's 2 plus 4 over x cubed minus 3x plus 6. And this whole part is being raised to the exponent of 4 plus the square root of 2x minus 5. Simplification is not required. So as you can see, we are back again, the first part, because of the exponent of 4. You're supposed to differentiate the same way of a function of a function. Drop the exponent, ignore that this bracket that we are seeing. Focus on the exponent on its own for now. So what are you going to do? We drop the exponent, so it's going to be 4. This remains as it is. Everything as it is. X squared plus 4 over what? X cubed minus 3x plus 6 as it is. Now we subtract a 1. So 4 minus 1 was going to give us what? A 3. We were focusing on the power. Whatever that we have must be multiplied now to the derivative of what is inside of the bracket there. The derivative. But as you consider the derivative of what is inside the bracket, what is that you have? This is a fraction. You are back to quotient rule, because that's a fraction, where this is your u and this is your v. Okay, remember your function of remember your quotient rule. How are you going to differentiate that from the condition of the quotient rule? Okay, our derivative from our formula sheet, that's v, first derivative of u minus u, the first derivative of v over what? Over v squared. So meaning to say we're going to take v as it is. This is our v. All right, so this was going to be x cubed minus 3x plus 6 as it is, like this. Then the first derivative there of what? Of u, which is our numerator here. So the derivative there is going to be 2x. All right. The derivative of 4, that's a 0 there. So I'm going to say it was going to be just a 2x. Okay. Minus, we move on to this. That's u as it is. This time I'm going to take our u as it is. That is x squared plus 4 times what? The derivative of v, the denominator, this one. So if you differentiate, this was going to give us what? 3x squared minus 3. Okay, that's a minus 3 there. 6, that's a 0, remember? Everything over what? Everything that you have there is over v squared. This is our v, but being squared. So that's x cubed minus 3x plus 6 raised to the exponent of 2. So meaning to say we have differentiated this first part. We have differentiated the first part. So I'm just going to put this in another, just like bracket like this. So this was the derivative of the first part. But if you check, we have a plus. A plus is allowing us to separate our derivatives, this on its own and this on its own. All right. So we're going to differentiate that now. So plus what? The 2x there that you're given minus 1 under the square root is same as 2x minus 5 raised to the exponent of a half, as we do understand our exponents. So the derivative, again, just like the previous case, guys, considering the power on its own, you drop the power. So you're going to drop the power. In that case, if you drop the power, what we're going to obtain, that was going to be 1 over 2 into what? The bracket as it is, it remains 2x minus 5. You subtract 1 on the power. So half minus 1 is what? That's a minus half. Times the derivative of what is inside of the, just like what we had there. What is inside of the bracket? Which is what? The derivative of what? 2x minus 5. That's a 2. So meaning to say this is what you're going to have at the end as the derivative of the last part. So you're going to consider this way. All right. This is what you were going to have at the end. So you differentiated the first part, then last part. Simplification is not required. You can even just leave your answer like that. Just like that. So you just have to work as much questions, guys, as much questions. 2.3. Calculate divide x if the cos of x is raised to the exponent of minus 2x with the aid of what? Logarithmic differentiation. So given that y is equal to the cos of x being raised to the exponent of negative 2, and you are told to use the logarithmic differentiation, simply introduce what? The ln. Remember your logarithms? We're going to introduce the ln both sides. So that will be the ln of y is equal to, this side you also introduce the ln. That is the ln of what? Of the cos of x being raised to the exponent of negative 2x. Which allows us to simplify this from our N3 mathematics. Remember, a ln is same as a log. So you can drop that exponent and give us what? Minus 2x times the ln of cos x, like that. Differentiating so that we obtain dy dx, meaning to say we are going to differentiate with respect to x. Differentiating with respect to x where we have y like this, it's impossible. So we are going to differentiate y as it is. The derivative of a ln y, it's what? Remember ln, first derivative over f of y. So the first derivative of y there is what? That is 1 over y. So you're going to obtain 1 over y. You are differentiating with respect to y, not with respect to x. So what are you going to do? You're going to multiply your answer by divide x, the condition that you do when dealing with what? Implicit function. In place of y, but you are differentiating with respect to x. You just differentiate the y as it is, the part of y there as it is. The normal way that you are used to, but you multiply your answer with what? Divide x. Okay? Which is equal to the right-hand side. We are not going to use that consideration because the right-hand side is in terms of x. Already we have x there. So we are going to differentiate as usual the derivative with respect to x. But these are two terms to be considered. The minus 2x is a term on its own. The ln cos of x, this one is a term on its own. So meaning to say, we are going to consider the product there. This is your u, this is your v. Product rule. How do you differentiate under product rule? U, the first derivative of v, plus v, the first derivative of u. So in this case, we're going to take our u as it is, which is minus 2x times what? The first derivative of u, which is the ln cos. Remember, ln, first derivative over f of x. So your f of x in this case is the cos of x, this one, the cos of x. What is its derivative? The derivative of cos x, that is minus sine x over what? F of x over f of x, the cos of x as it is. So that was going to give us what? A tan. Okay, or let's just write it for now, minus sine x. And do not know what's going to happen there. All right, so this is what we have, plus v as it is. Our v is what? The ln cos as it is. So this is the ln cos of x times the first derivative of what? Of u. Our u is minus 2x. What is the derivative of minus 2x? That's a minus 2. Product rule. So we can simplify this as we can consider that is 1 over y divide x is equal to, considering there a negative and a negative, we can take that one out and that will be a positive, and sine over cos is what? It's tan. So this is going to be 2x. Remember, sine over cos, guys, from your trigonometry, that is the tan of x. So you've got 2x tan of x here, multiply negative 2 to this plus. So it's going to be minus 2, the ln of the cos of x. You can write it better that way. So this is where you are. And as you can see, we are done with the derivatives, but we do not have dy dx. The question is, we need dy dx. We are not seeing dy dx. It's 1 over y dy dx. So this is affecting our answer, which is y. So how do we remove this? Just multiply by y this side. Also on this side, multiply by y there, so that you can cancel. So the derivative of y, we can now see it. It is equal to what? We multiplied by y there. So it's y into the 2x tan of x minus 2, the ln cos of x, as it is on the right-hand side. With respect to x, meaning to say we're supposed to have our answers here in terms of what? In terms of x. So this is supposed to be removed, substituted with its equivalent. What is the equivalent of y? Because we have it for here. Y is equal to what? Cos x to the exponent of minus 2. So meaning to say in place of y now, we cannot substitute that. Therefore, the derivative of y with respect to x, remember, y is equal to what? The cos of x raised to the exponent of minus 2x into what? This part as it is, the 2x. All right, gonna substitute this, write this as it is, 2x times tan x minus 2, the ln cos of x, like this. All right. So just make sure you do as much questions as you can, guys. Just try to work out as much questions as you can. These questions, they are not that much. They are not just that much. As you can see, it's just a repetition. You've been doing derivatives with us. You can see that they're just repeating these questions. So we just need to work as much question papers as you are revising. Just try to consider questions. So if there are any other questions, let us know, guys, on the comment section, which question paper that is having a challenge in terms of any topic, so that we specifically work on that topic that is having a challenge on that question paper. On 2.4, I need the marks. All right, that was 5 marks. 2.4, determine dy dx of implicit function. There we are given the tan of 3y. That is the tan of 3y minus y cubed, the cos of x, plus 3x y squared is equal to minus 4. If we are to consider the implicit function, remember, it's just a part where if you are differentiating y, you just differentiate the part of y as it is, but do not forget to multiply with what? Dy dx. So that is what you're going to just have, differentiate with respect to x, but considering that part. So you're supposed to differentiate each and every part. There is a tan there. Tan 3y. How do you differentiate this? Tan is supposed to give us what? A sec. Remember, we saw that. But this number is supposed to be there, here. You differentiate the 3y also. So it's supposed to be 3, then sec squared 3y. If you are given to differentiate the sign of 5x, the answer is not cos x, no. This is supposed to be also there. So as you differentiate this with respect to x, your answer is going to be 5 cos 5x. The number also is affected. So meaning to say, even if it is a tan, this number must affect here. So it's going to be 3 sec squared 3y. The next part that we can have, that we are seeing here, is a product. As we can see, let's just try to separate this. It's a product. This being multiplied to the cos of x. It's a product. Remember, y is supposed to be differentiated. So we have to consider it as a product there. We have to consider that as a product. So meaning say we've got our u and our v. All right, so that was going to be minus. Let's differentiate our product, guys, as we had our product in the simplification. Remember, as we are differentiating a product, we're using u, first derivative of v plus v, u like that. So what is your u? That is y to the exponent of 3 times the derivative of v. The v there is the cos of x. So if you differentiate a cos, that's a minus sine x, plus v, meaning to say our v as it is, which is the cos of x, times now the derivative of u. And if you consider your u as the term that is consisting y, That is the part of y there. So you're supposed to find its derivative. Then you multiply to dy dx. So what is the derivative of what? 3y. We're supposed to, okay, guys, remember here, this is second. I was trying to correct another part, and whilst I'm correcting that part, I'm also ignoring the major part. This was just an error which happened in the memo when they used they just like used sec cubed. It's supposed to be 3 sec squared, and having what? Your dy dx there. Do not forget, guys, your dy dx. Let us correct this part. All right. So like I was saying, on this part, you're going to differentiate 3, that is going to be what? 3y squared. Okay, you drop the exponent, subtract 1, but not forgetting our dy dx. All right, so that's it there. We are done. Our product, we are done. So let us just close this bracket. Move on to the other term, 3x. We do the same thing. This is your u, and this part is going to represent your v. So meaning to say, in that case, you're going to obtain plus u, which is 3x, okay, times y squared is derivative, v, the derivative there. So the derivative of y is what? Y squared. That is a 2y there, but having what? dy dx. Okay, then we're done with this. We move on to v. So we're going to have plus v. What is our v? Okay, so we are here. Here. The v is the y squared times what? The first derivative of u, which is considering 3x there. So if you consider this 3x, what is its derivative? That is going to be a 3. Remember, it's with respect to x, this one. So there's no effect of us using dy dx. We only use it when it's a function of y. You differentiate y as it is times dy dx. So we are done with this part. Then we can move on across the equal sign. Here, across the equal sign, what is it that we have? So across the equal sign, that's a -4. It's a constant. So the derivative is simply what? Is simply a 0. So that's it, guys. As you can see, you'll be having a lot of things, but do not consider it's Maths N5, guys. Maths N5, you know, they just want you to, this is really the stage where there are a lot of calculations and a lot of things to be considered. And then if you N6, you just like, this is just a repetition of much simpler, because you know the stages are supposed to be like this. But there's nothing that, it's not that much. You just have to work as much questions, guys. So let's see. First part, because we want dy dx, so we're just going to rewrite this as it is. Not forgetting the 3 there. All right, so let's consider the product, expanding the first bracket here. This whole bracket has to be expanded. So you're going to have minus and a minus, the first part, which is going to be positive y cubed, the sign of x, okay? Then this is a minus to a plus here. So it is going to give us a minus. But let's simplify what is inside. Let's try to simplify better. So you can just try write 3y squared, the cos of x, dy dx. Do not forget your dy dx. All right, we do the same thing on this bracket. It's plus, that's a plus, guys, just like a 1. So it just remains as it is there. So it's going to be plus. Let's multiply 3 times 2. That is going to be 6xy dy dx. Okay. Then we are done. 1 multiplies this. So it's just going to be a plus as it is. But you can just write as this one, 3y squared. Y squared times 3, which is 3y squared, is equal to what? To a 0. We have simplified our terms in a much better way. So now we can at least try to consider the terms or the part where we have the derivative of y with respect to x. The derivative of y with respect to x. The derivative of y with respect to x. As you can see, all of these, they are there on one side of the equation. So without collecting these terms to say, I'm going to take dy dx, I'm just going to factor it out, the dy dx, which is common. Factoring it out, what am I going to have in this? I'm going to remain with 3 sec squared. 3y like that. If I factor it out here, what am I going to remain with? this part, minus 3 y squared, the cos of x. If I factor it out here, what am I going to remain with? Plus 6xy. So we have affected the part where dy dx is and factored out that dy dx that we had. This is what you're having, which must be equal to what? We now take the terms where dy dx is not there. Yeah, here we do not have dy dx. Okay, let's move on here. This term, we do not. Remember, dy dx is affecting the whole of this term, guys. The whole of this term. The whole of this term. So this term, they do not have dy dx. You take them to the other side. Remember, there's a 0 there. So if you take this to the other side, it will be a negative there. Negative y cubed sine of x. You take the 3y squared to the other side, it becomes what? A negative 3y squared. That is what we have. You can divide by the bracket. By dividing by the bracket, you're obtaining what? You're obtaining the derivative of y with respect to x, since that is a product. So this is going to be left the right-hand side as it is. That's minus y cubed sine of x minus 3y squared as it is. But being divided now to this, which is 3 sec squared. So that was going to be 3 sec squared, 3y like this, minus 3y squared, the cos of x plus 6xy as it is. So this is what you're going to have now as your final answer, the derivative of y with respect to x. So take note, guys, on your simplification, as we saw here on the tan there, the derivative, if it is a tan of 3x, the derivative of tan 3x is 3 sec squared 3x. The 3 there has to affect. So only that this one, it was part of y, so we have to find the derivative, then dy dx. So if it is tan of 3y, the derivative has to affect also this part. So it's supposed to be 3 sec squared 3y, but multiplied to what? To dy dx, because this one, it's not part of x, it's part of y. So we have to include now the dy dx in our question. So guys, this is how our questions can be like in terms of our implicit functions. We just have to consider as many questions as we are revising. Like I said before, just try by all means to consider typical exam questions. And I think we've got a lot of exam questions under the derivatives. And if you check, maybe we actually did a question similar to this one. So do revise as much questions as you can so that you can get into exam prepared. So let's consider another question. That will be our question number 3. So considering question number 3, we can see that this is our basics of our derivatives, which is f of x. We are given f of x is x cubed minus 3x squared minus 3x plus 6. With this, determine the coordinates of the turning points of f of x, the coordinates of the turning points. What is it that you're supposed to consider at the turning points? The first derivative must be equal to 0. Remember that. So we're going to take our f of x, all right? So remember, your f of x there is given as x cubed minus 3 x squared minus 3x plus 6. And they are talking about the turning points. And we do understand that at any turning point, the first derivative with respect to x is supposed to be equal to 0. So thus we are supposed to determine the first derivative there with respect to x. Drop the exponent, it's going to be 3x. You subtract 1, so it's going to be 3x squared. Drop the exponent, it's going to be 6x. Subtract 1, minus 3x is going to be minus 3. 6, there is a constant, so that will be a 0. This is supposed to be equal to what? To 0. Now, as an equation from this derivative that you are given, equate it to what? Equate this one to a 0. That's an equation. Now, solving all the equation, guys, you can solve the way that you understand. You can even reduce this equation. You can see that 3 is common here, so we can just try to reduce our equation each and every term. So that will be x squared minus 6 divided by 3, that will be minus 2. 3 and 3 there, that's minus 1. 0 divided by 3, that's a 0. Minus 1, we do not have factors there that will give us a minus 2. So meaning to say we're going to apply or use our quadratic formula as we have it, that x is supposed to be equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So therefore, x was going to be what? This is our a, our b, and our c. So that's minus b, which is minus 2, plus or minus the square root of b squared. So that's minus 2 squared minus 4 times a, which is 1, times c, which is minus 1. All right, so this is what you are having, everything over what? 2 times a, which is 2 times 1. So simplifying this minus and minus, that was going to be 2 plus or minus. Just try to simplify this part under the square root. You try to simplify that, you're going to get a positive 8 there. So that's 8 over 2, which you can now use your calculator. You can even use your calculator at this stage. I'm not saying it's wrong, but just try to figure out what is inside of the square root. So the first solution for a plus was supposed to give you 2,414. And the other one, so let's just call this x1, or another x, just going to consider x2. On a minus, you are going to get minus 0.414 to 3 decimal places. Then substitute this into the original function now, because you need the corresponding y values. You substitute into the original function. So there's this trick that I want you also to understand, guys, dealing with these exponents, like dealing with these cubic function. We've got a lot of terms, like what you are given there, f of x is equal to x cubed minus 3x squared minus 3x plus 6, like that. You can simply do this way. On your calculator, I want you to learn this part of storing values. How are you supposed to store your values from your calculator like this? Let me just try. Let's hope this calculator can simplify the same way that I'm using on my other calculator. So if you're given values like the first value that we have, just try to have it this way. The first value that you are given, you store it on your calculator to store the value. This one, store this one. If you check its shift, then you press that, it can write store there. So you can store at any of these buttons with A, B, C, D, E, F, X, Y, M, those capital letters. You can store your answer in any of these. You can say, choose A, you can choose B, whatever that you want. So you write your answer as it is 2,414. Equate it. That's still your answer. Nothing has changed. What you just need is to store the value. So you have to equate it first. Then you store it. So it's shift store, that one, shift recall this one, that is shift store there. You press N of this, so I'm going to press A. So as you can see, answer is now in what? In A. My answer is being stored in A. It is now in A. So I can simply use A now in terms of this one. So I'm just going to take this, that is x to the exponent of 3. So I'm going to write this one. So to take that A, you press this button, recall this one. It must show there on top is to recall that value. Okay, so you just recall A raised to the exponent of what? Of 3, because A is containing this value here. So it is having that value in A. Do not worry about that. It is having that value in A. Okay, you move on. Minus 3 into, remember, recall A. So you press that button where A is, close that bracket. This is squared. Minus 3 into A. So you recall A again, close the bracket, plus a 6. So as you can see, it's better than to write this value digit by digit by digit by digit by digit. So guys, you can see that. Okay, minus 4,6. 5, this is going to change, the 8 is going to change 6 into a 7. So that is the y value corresponding to this y, to this x1. y1 is going to be minus 4,657. or move on to this other part. If x is minus 0.414. So this is what you're going to do on your calculator, because your calculator is already having this expression. So you just have to store this, because if you use that a, it's going to come back to this expression as it is. So take your answer again, minus 0.414 is equal to, okay? You store on the same part where a is, where that number was in a. So you're going to shift store at a. Our answer is now in a. So I'm not going to restart now inserting these values, pressing this button, going up, this one, going up, go up again. You can see your expression, this one, as it was a cubed, this and that. Because you have stored the a, which is a new value, if you press the answer button, this one, it is going to give you that answer which is corresponding to the a, that to this value that you now have, this one. So you're going to press answer like that. So you can see you got the answer 6.5, 6, and so on. So that is the y value there, 6.657 to 3 decimal places. So I'm not saying having those values as usual, as you used to have your values to insert 1 on your calculator is wrong, but I'm saying you can just do that in a shorter way. You store the values, then you can simply use as a stored value where that value is. So these are our turning points, as we have x1 corresponding to its y1. That will give us the first turning point, where x is 2.414. The value of y there is minus 4.657. And the other turning point is going to be at where x2 is given as minus 0.414. This is what you have for the x value. And the y value there is what? 6.657. So you now have your turning points, the first turning point and the second turning point. So this was your question, guys. Just needed you to have your turning points like that. Then 3.12, they want you to draw up the table of x. And f of x, the values of x and f of x, where x ranges from -2 to 2. So from this part of f of x, guys, this one, it was just to substitute here. You're not going to waste much time. Remember your x and your f of x. Your f of x simply represents the values of y that you have when you take your -2 to 4 as your x values. So starting from -2, that's -2. We move on, taking all numbers, that's -1. That's a 0 up to 4. 1, 2, 3, up to a 4. So this is what you're going to simply do, substitute. So you can even use that consideration of your calculator, guys. You store -2 on your calculator, then you simplify each and every part just like what we had. Okay, let me just try to illustrate this one. You're substituting into the original equation. So you take your -2 is equal to, you store it at what? At a. Then you go back on top like that. You equate. You can see that your answer is what? -8. You do the same thing when it is a -1. -1 is equal to, you store it at a, then you just go up to that expression. This one as it is equal to, your answer is what? Is a 5. When x is equal to 0, you're going to do the same thing. First, you have to store that 0. 0 is equal to, you store at what? At a. Then you go up to that expression is equal to what? A 6, and so on, and so on, and so on. So you're going to simplify these values into your calculator. This was going to give you a 1, a -4, a -3, and a +10. So that is what you simply have there as your table. Then from there, they want you to draw a neat graph of f of x between these values and show the turning points on it. Remember our turning points, we calculated, or we stated our turning points here. So with the table now, and also including this turning point, they are saying we are supposed to draw. So here I'm just going to have a sketch of how your graph was going to be like if you were to simplify, or if you were to draw these guys. So let us just say, okay, let's just try to have something which can help us. It's only that here we cannot win in terms of our Cartesian plan. But this is it, guys. Let's just consider this way. Remember your x-axis and your y-axis. Okay, this is too much. Let me just have a sketch so that we do not waste our time here, guys. So I'm just going to have our x-axis This is it. And also the y-axis. So it's going to be something like this. That's 1 up to 4. Let's say this is your 1, your 2, your 3, your 4. This will be your -1, your -2. Then you're going to have 1, 2, 3. Okay, this one up to 10. So there we can just even choose to use 2, 4, 6 instead of 1 because there will be a lot of points there up to 10. So you can just even try to use 2, 4, 6, 8, 10, 12, and so on for the y values. Okay. Then -2 going out down, -2, -4, -6 until we can accommodate the -8 that is there. So you can even put the -10. So you have your x values, your y values. You're going to indicate the points now on your Cartesian plan. You have your graph, you indicate -2 versus what? A -8, -2, and a -8. Where they meet, you mark a point, remember? So you're going to mark a point. -1 versus a 5. So 5 is in between 4 and 6 there on top. So it was going to be maybe somewhere there. 0 versus 6. That's 0 versus 6. 1 versus 1 in between 0 and 2. We're going to have a 1 there. 2 versus -4 going down, -4. 3 versus -3 somewhere there. 4 versus a 10 as you are going up. So this will be your cubic function, which you can even now join the points smoothly. You're supposed to join these points. So like I said, guys, as for me, I'm just going to have a sketch. Remember our turning point was between -0,4 something there. So this is supposed to go to a turning point. All right, it's supposed to be to a turning point, then it goes back. All right, after reaching the turning point, then it now goes back. The same way as we are moving in the negative region in this minimum values, this point is going to go to the turning point, then it has to return back. All right, something like this up to this point. So this is your f of x, where this one is a turning point and this one is a turning point. So the two turning points that we had, remember, we had these two turning points, the 2 comma and this -1 comma, as they are, these turning points. So definitely you can see that that one of 2,414 is supposed to be on the positive side. So this is the one that we have here. So this is the turning point where we are given it was 2,414 and the other part of y was -4,657. Considering on this other turning point, this is in the negative side. So this is the one that you're going to use of -0,414. And it was versus 6,657. All right. So make sure that you have your sketch properly, mean your graph drawn properly that way. So that is just like that, guys. Just like that. So let's consider the other part of our function, which is on 3.14. All right, so on 3.14, they are saying use the table and the graph to estimate the value of x. To estimate the value for the best root between x is -2 and -1 of this equation, then use the Taylor's. There's nothing about using the graph here, guys. To estimate this, there's not even need the graph to estimate that. Given the values there of x that you are given, we can estimate the root that we are going to have, the best root between these two. So the best root between these two, we can just take that one as x naught, which is simply, we just add those values of x that you are given here, this -2 and -1, the x values. So if it is 1 and 2, just add x1 and x2 over what? Over 2. So that is, you have that, -2 and what? -2 and -1. Just add those two. The average value in between is going to be your best approximate, and that was going to give us -1,5. And they are saying now use from that. We are supposed to use the Taylor's method or the Newton's method once to determine a better approximation of the root. If you take this is equal. So as you can see, this here is still the same function that we had. This one is still the same f of x that we had here. The same f of x that we had. So meaning to say, and they're saying you're supposed to use it once to 3 decimal places. How do we use our Taylor's method in simplifying any other root that you're going to have? So x1 is equal to, from x naught that you have, it's equal to x naught minus f of x naught, everything over the first derivative of that x naught. So when you're referring to f of x naught, we are taking from the f of x that you had. Remember your original f of x, that one that you had, it was x cubed minus 3x squared minus 3x plus 6. On that, you are supposed to substitute your f of x naught is this value, which is the minus 1,5. In place of x, every part where x is, substitute minus 1,5. So if you do it properly, you're going to get 0,375. When you talk of the first derivative, remember when you had the first, you differentiated this when you're calculating the turning points. Or anyways, we can even differentiate this. It's going to be 3x squared minus 6x minus 3. So this first derivative is the one that you're supposed to, here on the first derivative, substituting the same value of x naught that we have, which is minus 1,5. In place of x, you were going to obtain 12,75 in place of x. So these values are there, guys. You're going to substitute. This is the one that is representing f of x naught. This is the first derivative of x naught, this one. So with these values, you can simply substitute into the formula. So that's the first solution. Now, from that one of your better approximation, so it's minus 1,5 minus f of x naught, f of that x that we had, it's what? 0,375 over what? The first derivative, the numerical value, which is 12,75. So you're going to simplify this. So it was gonna give us minus 1,5294116. So to 3 decimal places, minus 1,529. So that is the first part. They just use it once. Just apply once. So you're going to end there. It was x2, you're going to continue with that. x1, where you are, you continue again and again until the part that you're given. So here they just said you're supposed to apply it once. 3.2, we are given the volume of a tree is given by this formula where C is the circumference of the circle at a ground level in meters. So C is the circumference in meters. H is the height of the tree in meters. Both C and H are functions of time in years. They are functions of time, meaning to say this C that we are given, it's written in terms of t. So the question was determine or find a formula for dv dt. What does it represent? What does the formula represent before you find it? Remember dv dt, the derivative of volume with respect to time. We are talking about the rate of change of volume there of the tree, because the tree there is given in meters. So the volume cubic meters. So you're simply talking of what? The rate of change of volume. The rate of change of volume with respect to what? With respect to time. That is the idea there. So they want us to calculate that. We're using this part that we are given, that V is equal to whatever that we have, and you're supposed to determine that dV dt. All right, let's take our V as it was, guys, and understand this question. It was an interesting question because they tried to hide something, but they, in fact, they failed to hide that. Let's see. Let's just see, guys. This was supposed to be, this was C squared H like this. They want to find dV dt, and they told you that C and H, this C and H, are functions of t. Are functions of what? Of t. So meaning to say, in them, we have t. In these, we have t in these. T is there. And this so meaning to say differentiating of volume with respect to t, and this part that we have, it is written in terms of t, guys. We simply have to differentiate each part. We simply have to differentiate whatever that you are given there. So this is what? 1 over 12, and we consider this a product, because this contains t, this contains t. So that becomes a product. So we can take this as our u. Remember our product, so we're going to take this as our u, and the other part as our v. Then we consider our product rule. U first derivative of v plus v, u like that. First derivative of u. So with respect to t, u, we're going to take our u as it is. It's not affected. That is c squared times what? V. V, the first derivative of v, which is the first derivative of h with respect to t. So what is the first derivative of h? That is a 1. The first derivative of h was going to give us a 1. But it is with respect to what? With respect to to t. So it's going to be dh dt. You do the same thing plus the v as it is. The v is your h times what? Derivative of u, which is the c. You differentiate your c, which will give you, the c squared is going to give us 2c. But we are given function of t. So with respect to c, we are going to have what? Multiplied these two dc dt. So it was an interesting question like this one. They are trying by all means to figure out how to just confuse us, guys. But there's nothing there. They are functions of t, so you just differentiate as usual, just like the implicit part. You differentiate c, but not forgetting dc dt. H, not forgetting dh dt. So this was going to be the derivative of your volume with respect to t. So you can just try to simplify this. It's going to be 1 over 12 pi into what? C squared. So this is just going to be c squared the h dt plus, if you multiply h times 2c, it's going to be 2ch or 2hc, whatever that you want there. That will be dc dt like this. So we have the derivative of the volume with respect to time, where c and t are functions which are also having that same time. And from 3.2 to now, they want you to suppose that the circumference grows at a rate of, the circumference, they are saying dc dt, the rate of dc dt is what? 0.2 meters per year. Remember, time is taken in a year. And the height grows at, meaning to say dh dt, they gave us the value of dh dt 4 meters per what? Per year, each and every year. How fast does the tree grow when the circumference is, we are now given the value of c, 5 meters. And the height is what? The height is 22 meters. How fast? The volume represented in number of years. So they gave us everything that you just need to substitute into the formula, because this is your dv dt. And from there, that's 3. Okay, it's another part, which is 3.22. All right. So it was just a matter of substituting. They are simply asking you the volume with respect to time. So that was going to be 1 over 12 pi into what? C squared. Circumference we're given. That is 5 meters. So it's going to have 5 squared times dh dt. You substitute your dh dt, 4 meters per year, plus 2 times c, the circumference, which is 5 times the h. What is the value of h? That is 22 times dc dt, the rate of change of the circumference per year, 0.2 meters per each and every year. So that was going to give us the rate, which is our dv dt. So try to simplify this. It was going to be 1 over 12 pi into, simplify inner part of your bracket, that was going to give you 144. Multiplying this on our calculator, that was going to be 3,819,718, something like that, which is simply, this was going to change into a 10, and that's a 2. So it was going to be 3,820 like that. This is volume per year. So it's cubic meters per what? Per year. So it is going to have that as a volume per year in terms of the growth that is taking place. So it was just a matter of substituting into the answer this derivative that you already made. You substitute your values that way. So that is it, guys. As you can see, they are trying these days. The department, guys, they are trying to give us try as something. So, but there's nothing that is new, because we talked about these questions, guys. We just need to make more questions, just to revise. Find the positive number. We had a similar question, but here I've forgotten the name. But I think when I introduced this part of maximum and minimum values, we had a question like this. They're saying find the positive number where the sum of that number, once you're given a certain number we do not know, so let that number be x. Let the number be x. So they are saying the sum means what? You're adding. So the sum is going to be x plus, and what? You're adding that number and its reciprocal. And its reciprocal. What is the reciprocal? The reciprocal of 2 is 1 over 2. The reciprocal of 3, 1 over 3. So what about the reciprocal of x? That is 1 over x, the inverse. But it's not ending there. This is just the sum. But they are here, they're saying the sum is minimum. We are back to minimum, those maximum and minimum values. So if this sum, as we can see, it's written in terms of x, and it's x plus 1 over x. For this sum to be minimum, what is it that we understand? The first derivative with respect to x must be a 0. If we differentiate this with respect to x, we must have a 0. So that is the consideration. So what is the first derivative? X is going to give us 1 plus, this is 1 over x, okay? Remember, 1 over x is same as x to the exponent of minus 1. So when you differentiate, you drop the power. It will be minus 1. X to the exponent, you subtract 1. So that will be a negative 2. So this is simply negative 1 over x squared. So this was going to give us negative 1 over x squared. So plus and minus, there is simply a minus 1 over x squared. This is the first derivative with respect to x of the sum. But they are saying it's minimum. It must be equal to 0 for this to be minimum, the first derivative. So we're going to take this, equate it to 0 as it is. That's an equation that you need to solve now. So you can just say 1 is equal to, take this to the other side, it becomes a positive there, 1 over x squared. So cross multiplication here, guys, can be done. You can even cross multiply and see what's going to happen. 1 times x squared is what? X squared, 1 times 1 is 1. So to determine your x, just introduce the square root, knowing that square root of any number is plus or minus. But they specified that the number that we're talking about is what? Find the positive number, the positive one. There are two answers there. Which one is positive? That is the one that we need. So therefore, the number was going to be 1, the positive. So the number that is giving us that consideration that we are given there was going to be a 1. So this is it, guys, about your minimum values. We just have to use the condition that you're given there. They can even use consideration of area and volume to be minimum. You just have to apply according to what you are given. Question number 4, integration. Determine the integral of y with respect to x. In each of the following cases, on 4.11, you're given integrate. That is the cosine of 3x times the sine of minus 7x. So if we consider our trigonometry, we can see that these identities are there that affect the sine and the cos. If you check properly here, there's this identity where we have got cos and sine at the same time, cos and sine here, cos of A, sine of B. If you check this identity, you're going to have half of sine A plus B minus. So using this identity, you can see that we can expand that because there are two things that are different there. There are two trigonometry terms which are under a multiplication and being different. So let's start by that and see what are we going to have at the end. Remember, we saw that this is given, or this was given as the cosine of A times the sine of B, which is equal to half into the sine of A plus B. So I want you to properly understand this so that we do not have confusion here. Sine A plus B minus sine A minus B. So this is your identity, this one. So taking this to be our A, the first term to be our A, and this to be our B. Those are the ones that you are referring as your A and B in this case. So this is our A, this is our B. So it means if you were to simplify that, cos of 3x the sine of minus 7x, what we're going to have, it was going to be half of what? The sine of a plus b. A, which is 3x, plus b, our b is minus 7x, okay? Minus the sine of a minus b. So this time it's a minus b. Remember our a, that is 3x, minus b, and our b is a negative 7x. So there we had positive, negative. What are you going to have here? A negative. So that will be half of what? Sine 3 minus 7, which is minus 4x. Minus, they've got a minus and minus, that will be a plus. So 3 plus 7, which is going to be what? A 10. So that will be 10x. So this is what you're going to actually have at the end. But considering our trigonometry, yes, we can work with this, but our trigonometry also tells us that in the fourth quadrant where we have a negative values, the sign of a negative value is equal to minus sign of that value that you are given being a positive. So if I'm given sine minus x, remember your trigonometry, guys, from your N4, you were writing this as what? Minus sine x. It was the cos of x which was not changing. Cos minus x is the same as the cos of x. That one, there is no effect. And here we do not have even a cos, so we're not going to even focus with that one. The sine minus gives us minus sine x. So what does it tell? We have the negative here. So it tells us that we can just rewrite this as what? Minus the sine of 4. We are just avoiding to have this as a negative. Not to say if we work it like that, it's wrong. No, we can even use like that. But guys, let's just try to go into our mathematical simplification also, if possible. All right, minus what? Minus the sine of 10x. We were using the identities here. There is no integration which has happened. It is just the identity that we are still simplifying. This is where it is going to end. With this, we can now integrate. Instead of integrating this now, we're going to integrate that identity that we have now. So we're going to even take the half, as you can see, it's not affecting. Take it outside of the integral. Then this part as it is that we have here. So we're going to take this part inside of the integral. So we have got minus the sine of 4x, then minus the sine of 10x as it is like this. We integrate this with respect to x, just like that. So that is where these identities play a role, guys. That is where they play a role. At this stage, you can integrate now. Remember, this is easier for us to integrate. Integral of a sine. Remember, sine, when you integrate, changes to a cos. So it will be negative cos. Negative cos 4x over what? You divide by this number, 4. Sine changes to a negative cos. Already there's a negative here on our formula, but when you integrate a sine, it changes to a cos. So that's negative cos 10x over what? Over 10. You divide by the term that is on x. So this is what you're going to have plus the constant of what? Integration. So we can just simplify this, guys, multiplying by half inside. So considering the numerators together on the first term here, it was going to be 1 times minus 4x. You're multiplying. So that's a positive. Minus, that's a plus. So it was going to be the cos of 4x over what? 2 times 4, which is 8. You do the same thing, 1 times this, but minus and minus is what? It's a plus. So 1 times the cos of 10x, that is the cos of 10x over what? 2 times a 10, which is a 20. Plus what? The constant of your integration. So with this, I have it as your final answer. So questions can be like that, guys, where they need you to apply your identities first, as we saw here. You're supposed to use your identities. And after, we can now integrate each and every part that you're given. On 4.12, that is sine. All right, they just try to play around with us because in our simplification, like in our integrals, we never saw something like this. We never saw something like this. 4.12, the integral of sine to the exponent of 4x times the cosec of x. How can these two be on the same question? How is that possible? because the cosec of x is equal to what? 1 over sine of x. So you cannot have something like that. So let's get rid of this in terms of what? In terms of this simplification. So meaning to say in this integral, we simply have sine to the exponent of 4 times what? Cosec is 1 over cos dx. It's 1 over sine, sorry. Where am I getting the cos, guys? Now, where am I getting this? Is mind tired? Mind that is being tired? I don't know. So it is. Let us expand. Because this can be divided. Remember, it's a numerator that you have. So sine x into this. How many of them there are here? There are 4. So if we divide, we're going to remain with what? With the 3 of them. So that's the cosec is no longer there. The cosec is no longer there. We are just left with the normal sine cubed x that we are used to. How do we integrate this? Remember from your trigonometric expressions working with is a sign when being given an odd power can be separated in terms of sine squared x times the sine of x. Knowing that we have got an answer for this because cos squared x plus sine squared of x is 1. So you can make this the subject. So it simply means we're going to have sine squared as 1 minus what? Cos squared x in place of what? Sine squared x. So in place of sine squared x, we're going to substitute that 1 minus cos squared x times the sine of x. Let's expand this and see how it's going to be like sine of x times this is going to be sine of x. The sine of x times the cos is going to be minus cos squared x times the sine of x. So this is what you're going to have from this simplification. So you're going to have the integral of the sine of x minus the cos squared x, the sine of x with respect to x. And this allows us to integrate each part separately. These are 2 terms separate, so you can integrate the sine of x with respect to x on its own. We can integrate this on its own. So it's minus the integral of cos squared sine x with respect to x. So this can be integrated. Knowing our integral, as we had before, sine was changing what? To a negative cos. So that's negative cos. Minus the integral of this. How are you going to integrate this part? Here, using substitution method. You can let, or you can take u to be what? To be the cos of x. If we let u to be the cos of x, it means we're going to need the derivative of u with respect to x. Remember your substitution method. That's negative sine of x. Then we make dx the subject. So you're going to multiply du is equal to minus sine x dx. Divide by what? The negative sine x both sides. Negative sine x both sides like this. So this is our dx that we are going to need in the substitution. That's du over what? Negative sine x. So in integrating these guys, we are going to integrate this as the integral of where the cos is, but it's u now. It's u that is there, and it's u squared times the sine of x times the dx. Remember, our dx is now written as what? Du over minus sine x. Remembering that this will cancel always. So we are left with a negative there. So it's negative the integral of u squared. With respect to u, the negative goes there. So we're integrating this. This is u, guys. U, this one. Raised to the power of 2. How do you integrate? Add a 1 on the power. So it's going to be u to the exponent of 3 over a 3. So this is what you're going to get from this u. And the u, we have it. What is the u? Is the cos. This one. So it simply means we've got minus cos to the exponent of 3x over what? Over 3. From this integral, that is what you're going to actually obtain from this integral. So take note this one. Because if you check your memo there, they just made a mistake on simplifying. So this was going to give us a negative at the end. So we've got negative cos cubed x over what? Over 3 like this, plus the constant of integration. So you can simplify minus cos of x minus minus, that's a plus. So that's cos cubed 3, cos cubed x over 3, plus the constant of integration. Yes, so as you are using your memos at the same time you're working with the memo, try to be vigilant also as an individual to check the way that you understand. Is it the way that they're presenting there? Because sometimes they do make mistakes and you're just taking as it is. All right, so please make sure that you work out as many questions as you can. That was our 4.12. 4.13, that is part of our long division. Remember there we've got an improper fraction. The denominator is actually something else in terms of the exponent, smaller compared to the numerator. So you're going to apply our long division. So that was going to be x plus 4 into the what? The numerator, x cubed minus 3x squared minus 10x plus 24. Let's divide. Remember, division, first term versus first term. This one versus this one. So x cubed divided by x. How many are we going to remain with? Two of them. So it's x squared there. Whatever that you get is supposed to multiply this term as it is. So it's x squared into x plus 4 as it is. So it's x squared and x, which is x cubed. X squared and 4, x squared times 4, which is what? Plus 4x squared. Then subtract. Remember your steps, guys. Then you subtract. So subtracting these two, what we're going to have? X cubed minus x cubed, that's a 0 there. Minus 3 minus a 4, that's a minus 7 x squared. Then we drop these terms which are remaining. What is remaining? Minus 10x plus what? Plus 24. Divide again. Always first term versus the first term. So that's minus 7x squared divided by x. So you can see it was going to cancel. You remain with 1x there. So it's minus 7x, which will multiply everything that we have there. So just like the previous case, minus 7x into what? X plus 4. This part as it is. Minus 7x and x, it was going to give us what? Minus 7x squared. Minus 7x and a 4, that was going to give you minus 28x. You multiply it to this part, everything. You subtract after that. So let's subtract. As you can see, these two terms are the same. So by subtracting, that is going to give you a 0. Then we move on to the other term, the minus 10 here, minus 28. So it's minus 10 minus 28. As you can see, that will be a plus. 28 minus 10, which is 18, but having what? Having x. So that was going to be 18x. You drop the term that is remaining, the 24 plus 24. Divide again. First term versus the first term. This first term to the first term. So 18x divided by x is what? That was going to cancel, and you've got what? Positive 18, which is going to multiply everything just like what we had. 18 here multiplies everything. So it's 18 times x, which is 18x. 18 times 4. That was going to give us plus 72. Subtract, just like the previous case. 18 minus 18, that's a 0 there. 24 minus 72 was going to give us minus 48. As we can see, we do not have x. So you cannot divide this 48 there, minus 48 and x. It's going to be something minus 48 over x. It's not going to work. We cannot divide. So what does it mean? This term is now our remainder. So when we divide it, what is it that we got? We got this as our answer. So we're going to take our answer, which is what? This part, x squared minus 7x plus what? Plus 18. So this is what you're going to have at the end. After dividing that part, we were going to have this as x squared minus 7x plus 18, which is this as it is, plus the remainder. Our remainder is what? Minus 48. So you're going to take it as it is, minus 48 over what? The dividend. What was dividing? You were dividing by what? X plus 4. So you divide to that over x plus 4. So remainder over what was dividing. So this is the part that we had here of that long division here, this long division, this one. At the end, it will give us something like this. So if it was under an integration, that means we are simply going to integrate everything that we are seeing here with respect to x now, because this are separate terms that we have there. So what is the integral of x squared? Add 1, that is going to be what? If you add 1 to the exponent of 3 over 3. We add 1 here, so that will be minus 7x squared over 2. Here, just going to put x there, so that will be plus 18x. Remember this integral of the fraction, guys, when I talked about this fraction, I think I did those formats of 1 over ax plus b, this and that. Here is just a 1. So do not consider anything. Just going to take your constant as it is, minus 48, the ln of what? Of x plus 4. Remember, these ones, they change into a ln. If you are given the integral of this nature, k over ax plus b with respect to x, you're integrating this type of equation. It's going to be k over a, the ln of ax plus b. So in this case, our k is 48. So it was going to be 48 over a. The coefficient of x is just a 1. So as you can see, that is why we just remained with the 48. There was no effect there, k over a. So that is how you integrate this type of a question. But if you check on the videos, I managed to do that as a separate topic, So make sure that you go through that. It can help. So that is it, guys. You're done. There's nothing that you can do here. It's nothing that you can do, as you can see. Your long division as usual. Then on 4.13, there's a product there. It's supposed to 4.14, that is the product of 2. Integral of x cubed, the ln of 4x with respect to x. We're dealing with a product. So definitely you're going to think of what? Substitution? No, as this cannot work. You cannot cancel anything. So let's think of by parts. Remember, by parts method also under a product allows us to differentiate terms under a product. Integral of f of x g prime x dx is equal to what? F of x by gx minus the integral of the f prime of x gx dx, like this. Remember that. F of x, something that we can differentiate, then the remaining part can be integrated. So if we choose this to be our f of x, you see that you are remaining with a ln, which is difficult to integrate. So it was going to be best for you to choose the ln to be your f of x. So in this case, on our calculations, we are going to let our f of x to be the ln, this one. We choose it to be our f of x. So if we choose ln to be f of x, it means the remaining part now, which is of the g prime x dx, is what is remaining. What is remaining? X cubed and what? X cubed and dx. It's not about the order to say this order is supposed to take as it is. If it is the first term, that must be your f of x. The remaining part is, no. You can choose the way that you understand the f of x. Easier to differentiate a ln. We saw that the derivative of a ln, as we said, guys, is going to be first derivative of f of x over what? F of x. So the first derivative, your f of x there is what? Is a 4. So this was going to be 4 over what? F of x, which is 4x. So that was going to give us 1 over x. From the g prime x that we have, what are we going to obtain? The integral from there. Obtain gx by integrating. This will give us gx. If you integrate, remember, add a 1, so that's x to the exponent of 4 over 4. These are the ones that we need into the formula in order for us to integrate this. We need f of x, we have it, which is the ln of 4x times the gx. Remember, here our gx, x to the exponent of 4 over 4. All right, minus, if we move on to this, we have got the integral of what? F prime x, which is 1 over x. We calculated this, the first derivative times what? The gx. Our gx as it is x to the exponent of 4 over 4. So this can be integrated with respect to x. Is it possible for us to integrate? All right, let's just rewrite this. X to the exponent of 4 over 4. The ln of 4x, just going to rewrite this way, and we try to integrate here. Taking out the x, simplifying this part of x into x to the exponent of 4, it was going to give us x to the exponent of 3. So we can take out this 1 over 4, this one, out of the integral sign. So it will be 1 over 4, the integral of what is remaining, which is x cubed dx. And looking properly, we can see that it's something that we actually integrated here. X cubed, we got what? X4 over 4. So meaning to say we already integrated this. X to the exponent of 4 over 4, the ln of 4x remains as it is, minus 1 over 4. We integrate this. So we saw that it's going to be x to the exponent of 4 over 4. Then we can have our constant of integration, as we do not have any integration left. So this is what you have. You can even leave your answer like this. You can even expand if you want. That is x to the exponent of 4 over 4, the ln of 4x. So expanding this, 1 times x to the exponent of 4, that's 4 over 4 times 4, which is 16, plus the constant of integration. So you can actually have your answer that way in your simplification. So questions can be of that nature. Questions can be of that nature where they are asking you to simplify, integrating in that consideration. So you are supposed to be very careful as you are to simplify each and every integral that you are given. Is it by parts that you are given there? Is it the issue of the long division? Whatever that you are given. On 4.2, they want you to determine the integral of y with respect to x, but we are given by resolving the integral into partial fractions. All right. So let's consider what we are given there. That's 4.2. So on 4.2, you are given that is the integral of 2x minus 1 over x plus 3 to the exponent of 3 with respect to x. So if you check your memo, they just made a mistake in terms of calculation. They were using x plus 1. Yeah, it's actually wrong. It's supposed to be x plus 3. So do not know, guys, that these mistakes like that, but there are too many mistakes in this question paper. Let's just hope with time, all these shall be resolved. All right. So given this, guys, we have to apply partial fractions as we are told. This is a repeated linear factor. And as we do understand, our repeated linear factor can be expanded in this manner. You can take a over the first linear factor, which is x plus 3. You will be increasing powers up to 3. Start with 1, 2, up to 3, or you can start with 3, going down 3, 2, 1. So it's up to you. So in this case, I'm going to take them increasing from 1. I move on to 2, up to the power that I'm having there, which is 3. So it's c over what? X plus 3 raised to the exponent of a 3. Just like that. So this is what we have. Now we can simplify this, equating to the numerator or working with the numerator. That means 2x minus 1 is going to be equal to what? Start with a, so it's a into what? This into this bracket. How many are we going to remain with? We're going to remain with the 2 of them, the x plus 3, 2 of them. If you divide here, they're going to be 2. Plus these ones, they are 2. So if you divide here, how many will remain? Only 1. So it's x plus 3. These ones, they are 3. And you divide to these ones, which are 3. How many will remain? Nothing. They will just cancel. So this one, it will be plus c. This is where you are. Letting x to be equal to minus 3 was going to allow us to eliminate one of the brackets there. I mean, this bracket and this one, these two brackets. Because remember, x plus 3, they take that x plus 3 equate to 0. X is what? X is minus 3. So when we let x to be equal to minus 3, it means this will give us a 0. This will give us a 0 because we saw that x plus 3 was equated to 0 there. So you substitute this side, 2 into minus 3, minus 1 is equal. This one will be as 0, as 0, as 0. So you just remain with what? With c. 2 times minus 3, minus 6, minus 1, which is minus 7. You can just even use your calculator there. There is nothing that we can also equate. So it will be easier for us to just expand our brackets, equate the coefficient, because here we can see that we are stuck. We do not any. I have another bracket that we can say, let this bracket be equal to 0, then we can. So let's try to expand brackets. Expanding by expanding. All right, so we're going to have 2x minus 1 is equal to, let's expand the first bracket. Remember, guys, this is your n3. It's going to be x squared plus 6x plus 9, okay, when given a squared like that, but it's being affected by a. A times this is going to be ax squared. A times this is going to be 6ax. A and 9, that will be 9a. You've expanded your brackets. You can even use two brackets as they are, x plus 3 into x plus 3. You expand x multiplies here, x squared, x and 3, which will be 3x, 3 and x, which will be 3x, the 3 and the 3, which is 9. Considering like terms, you are going to have the same part, x squared plus 6x plus 9. All right. Then the other part is b, which is just into this linear bracket. So b times x was going to be what? That's bx. Then b times 3, which is 3b. Then c, there's no effect on that c. So by expanding, it allows us to equate the coefficients now. Let's say we are equating the coefficients of x squared. Here it's like we have got 0x squared plus 2x. So the coefficient of x squared there is what? Is a 0. What about on this side? Do we have any part where x squared is? Yes, we have it. X squared, the part of a. The coefficient, it's a. So meaning say a is equal to 0 automatically, because we do not have any other part where a is on x squared. I mean, we do not have another part of x squared that is there. So you just take that a to that one on the left-hand side, which is supposed to be a 0 because it's not there. So it means it was 0x squared. So that is the idea there. So moving on to the coefficient of x, considering the part of x, the coefficient of x. What is the coefficient of x here? 2. So 2 is supposed to be, we take where the coefficients of x are. There is x here. What is the coefficient of x? 6a plus 6a. We have got x here. What is the coefficient of x? That is a plus b. But remember that a is equal to what? A is equal to a 0. So meaning to say 2 is equal to what? 2 is equal to b. Remember, you calculated the c already on that part where c is minus 7. Using this with any other part where c is, you can even prove if you take the coefficients, then you see that you're going to have the same thing. So this is how your questions can be like. So we do not have the part of a, we have b and c. So we're going to substitute now there on this part that we have. Remember, our a is what? So I'm going to just erase this so that we substitute our values. Remember, our a, we got a 0 there. Our b, that was a 2. And our c, that was a negative 7 in place of c. So I'm just going to remove this guy. So that is how you play around with these questions. Just try to properly expand your terms as you are simplifying. But from there, you can actually combine where it is possible. Then it's just have to matter. It's just a matter of how the question is given, guys. So this part of our integration at the end, it simply means it was going to be what? Integral of 0 over this, meaning say there's nothing there. So you move on to 2. So it was going to be 2 over what? X plus 3 squared. So this is x plus 3 squared minus 7 over what? X plus 3 to the exponent of 3. This is what you're going to have at the end. So you're going to integrate this with respect to what? With respect to x now. So your partial fractions, they helped you to expand this into fractions that you can be integrate. Can we integrate this? Remember your substitution method. You can try that, letting u to be equal to x plus 3. That means du dx is what? That's a 1. So meaning say du is same as dx. So using the substitution method here, you were going to obtain this way. It was going to be the integral of 2 over what? This is now u raised to the exponent of 2 with respect to, remember, du and dx is the same. minus the integral of 7 over, this was going to be u to the exponent of 3 with respect to u. This can be integrated if we have it on top there. So how do you write it on top? We just write it with a negative exponent. So it was going to be 2u to the exponent of minus 2 minus 7 u to the exponent of minus 3 with respect to u. Remember, I want to integrate. Integral, we just add 1 on the exponent. So it was going to be 2 u to the exponent of what? If we add 1 minus 1, we divide by the new exponent. Minus 7, we do the same thing here. We add 1. So what are we going to have? U to the exponent of minus 2 over what? The new exponent, which is minus 2. Which we can simplify here because we can see, guys, the minus here can just be same as we've got minus 2u to the exponent of minus 1. So it is same as minus 2 over what? Over u. Minus and minus can cancel. So here is same as we've got 7. It was going to cancel and give us a plus. So it's same as we've got 7 over 2. The u taken down, so it will be u squared like that. This is what you're going to have. So with the u that we had, which is our u, it's what? X plus 3. You're going to substitute now. So this whole integral was going to be minus 2 over u. What is our u? Remember, we said let u be what? X plus 3. So that's minus 2 over x plus 3 plus a 7 over 2u squared. You remember our u, x plus 3 squared plus the constant of integration. So that can actually allow us to integrate by the substitution method. So I want you to go through your substitution method, your basics. We talked about these guys, but just go through. It can be very helpful as you are to consider your simplifications or your revisions. So let's consider this other part. All right. So that was question 4. Okay. All of it. Question 5, which was part of this question, it was similar. If we check the question paper of November 2022, I want you to check that. You see that it's a similar question, and I think I discussed about this question. So actually, there's nothing, guys. For those who have been watching our videos, this type of a question is actually nothing. If you are given this type of a question, this is just a repetition. We are given that if f of 2 is 5, f of 0 is 1. Then evaluate this. Okay, let's just have our question so that we can understand it much better. You are given f of 2, its value is 5, and f of 0 is equal to 1. Then evaluate. So here you are being asked to evaluate the integral 0 to, that was f prime x, f of x raised to the exponent of 2 with respect to x. So I said, when you're given this type of a question, just consider to say, already we've got a function, and this is a simplification that you just need. So from these values, like if you sub f of, is from a function of x. So we can introduce that and say, let u be equal to f of x. If u represents f of x, thus du is going to be the first derivative of x. With this understanding, guys, we are going to consider to say we are going to change this into u. We are going to change it into u. So meaning to say also the limits, they are supposed to change. These limits were for x. So we need the limits for u from this. That is where the limits are. Remember, the consideration of the limits is going to be the lower limit from the lower value, f of 0. Remember, u represents f of x. So in place of x, they just put a 0 and they say the answer is what? Is 1. So from f of 0, you have what? 1. That is your lower limit from the lower value. The upper limit, the bigger value there, that is your upper limit, u2, which is f of what? F of 2, which is what? Which is 5. So you've got your lower limit and you've got the upper limit of the integral. Remember, guys, the integral that you're supposed to make. You're supposed to make an integral there, which is now in terms of u because we introduced u. So we need the limits for u from this one, u1 and u2. So this is just like u1, and this is our u2. Our u2, which is what? Which is 5. Answer there, it's 1 and 5. Lower limit, upper limit. These were limits presented for x. So if we say there is a u like that, there is a u like this one. If f of x, I want us to understand here, guys, if f of x like this is equal to u like this one, this u that we are seeing here, what about the first derivative? Instead of us writing du, but in terms of this derivative, if you differentiate, it means you're also going to differentiate the u. Differentiating u will give us a 1. So you'll find out the part of that first derivative. It was going to be just like a 1 like that. Then we've got f of x squared in terms of u. F of x as it was originally, it was what? Your f of x from this concept. Your f of x is u. So if you square it, you're also squaring this. So this will be what? U squared. With respect to u. We can it's a new question now that has to be integrated this in terms of u. Those were the limits for u. So now this one is no effect, but we saw where the one is from. So we are integrating with respect to u. So we're just going to add a 1. So that's u to the exponent of 3 over 3. And the limits are there for u, which is 5 and 1. Just like that part of change of limits. Remember change of limits. They can do it like that. They just want you to have confusion, guys. You know, these exam guys, they are like that. So substitute upper limit minus the lower limit in place of u, that's 5 to the exponent of 3, exponent there, over 3, minus the lower limit in place of u, 1 to the exponent of 3 over 3. That was going to give us 124 over 3. So we have to simplify properly there. So like I said, guys, this is just a repetition. November 2022 question. Just check it and see so that you can try to do it with this question. Now you can add up and see, okay, this is how they can even ask. From the indefinite integrals we are given, show that f of t is equal to p. Show that if f of t is, okay, if, here, if. Meaning to say, in place of f of t here, we can remove it and put what? And put p there. That is what they are simply trying to say. So 5.2, you're simply going to integrate this. We've got infinity there, then e to the exponent of minus 2t, and in place of that, you're going to put a p. That is what they mean. P is a constant, so you can take it outside of the integral because we are integrating with respect to t. So we're going to have a 0 there, infinity, e to the exponent of minus 2t with respect to t. Guys, let us integrate. I talked about this indefinite, where we've got infinity values there, substituting of infinite. But anyways, let's integrate. What is the integral of e? E to the exponent of minus 2t over what? Over that derivative, which is going to be minus, considering e. So that is, we're going to have p, then we integrate this. E to the exponent of minus 2t over what? Over minus 2. The limits taken from what? From 0 to infinity. It will be difficult for us to actually analyze the infinite when having a negative exponent. Let's use our exponents, drop the negative. So this will be what? If you drop this one, negative, you remove that negative, it means you're dropping this down. So it was going to be minus 1 over, remember this negative here, guys, can just, it's the sign which is affecting everything. You can just write it here and remove it here. But as we need to drop the e to remove the negative on the exponent, you remove it by 1 over that. So it will be 2e to the exponent of what? Of 2t. This is just to allow you to properly substitute the limits that you are given there. Upper limit minus the lower limit, as we do understand, minus 1 over e to the exponent. Remember, that's infinite and there's also the upper limit, so it's 2 times. Guys, we have infinity there on top, like 2 times infinity, guys, is just an infinity value. Minus, okay, the formula, minus for the formula, the lower limit. We substitute this minus 1 over 2 e to the exponent in place of t. 2 times 0 there, that's what? That's a 0. So this is our lower limit. Upper limit minus the lower limit. There is an infinity there. Infinite. E to the exponent of infinity is infinite. And back to our infinite, 1 over infinite approximates to what? To a 0. So this part here, because it's like 1 over infinite, the whole of this part will approximate to a 0, as it is this part. From the concept of what? Our infinite there. Remember your limits, guys, as you had from your N4. This will approximate the whole of this to a 0. What about this part? E to the exponent of a 0 is what? Any number to the power of a 0 is 1. So this one, we can have an answer there. But this one will give us a 0 from the infinite part that we have there. So meaning to say, we're going to have P into what? That's a 0 there. Minus and minus, gonna cancel, that's a plus. So we've got 1 over, remember I said this one is what? This one is now a 1. E to the power of a 0 is 1. So 1 times 2, that's a 2. Just like that. So this is where you are. 0 plus half, that's a half. So P times a half is going to give us what? Half of P, which is simply P over 2. Half of what? Half of P. So that is how it can be like, guys, considering where you have to apply those infinity at the end. I just want you to have your basics. The limits, as you consider the limits there, infinity is there. How are you consider the limits? All right, so here it was just a typing error. Here we can see this is the question that we had here. All right, so let's just ignore that one. 5.2. Given below is the graphs of the functions y is equal to 3x squared plus 5x plus 2 and y is equal to minus x, showing the points of intersection and the area bounded between the curves. Everything is given. If you take a closer look with points of intersection, so you've got the x value there, and the point of intersection, we also have the x value there. The limits, remember the consideration of lower limit, upper limit, x1, x2, or just considering the value of a and b as you are doing those limits, the way that you understand them. So this is what you're given, and analyzing our graph, we can see that the graph of y is equal to x, this one, is on top. So we consider this as y1. And this one, which is below, let us just call it y2. Depending on the way that you want to mention them, you can even call this y2 minus y1, depending also the formula. But as for me, I'm going to take the top to be y1 and the bottom to be y2. Remember, when you are calculating area, because definitely we need area there. Remember, when you're calculating area, how do you calculate your area between the two functions like what we are given there, 5.31? So the area with respect to x is going to be the integral. Given the limits a and b, we're going to have y1 minus y2, which is the top minus what? Minus the bottom part. The one that is on top minus that the one on the bottom. With respect to x, we can have what? Our area. So that is why you have to be very careful. So the limits, x values, what is the x value there? Minus 1,577. What is the x value on the other point? Minus 0,422. Lower limit, upper limit. Then we're going to take our function y1 according to the one that is on top. That is y is equal to what? Minus x. Part of x, minus x, minus y2. The y2, which is the one that is below the quadratic. As we can see, within that region that we are calculating the area, it's the one that is below. It's one that is on the bottom. So you're going to take that as it is, subtract 3x squared plus 5x plus 2. This is the function that you're supposed to subtract. Then you can integrate with respect to x. So considering this, guys, the area was going to be calculated. Let's just try to simplify this. That's expand with a negative. It was going to be minus 3x squared minus multiplies 5x. It was going to be minus 5x minus times 2. It was going to be a minus 2. So you've expanded with a minus there. So meaning to say we are going to have minus 3x squared, considering the like terms, minus x minus 5x minus x minus 5x. It was going to give us minus 6x. It's just like minus 1 minus 5. Okay. So this was going to give us minus 6x. And there's a minus 2 that is there. With respect to x, we can integrate each and every part that we are given there. So we are going to integrate each and every term that we have. Let's integrate. So the area with respect to x was going to be what? Integrating this, add 1 here. That is minus 3x cubed over 3. This was going to cancel. And we have got minus x cubed. Part of minus 6x, already there's a 1. So if we add a 1 there, it was going to be minus 6x squared over 2. Cancel this. That was going to be minus 3x squared. Then the 2 is a constant. So if you integrate, you're just going to put x there. So this was going to be minus 2x. Our limits, not forgetting upper limit and your lower limit, like that. All right. So I talked about this issue of storing the value and then substituting. That is where now you see the importance of these guys. Because in this case, we're going to substitute this upper class. Remember the issue there, where the upper class, the place where x is. You substitute this value here. So I'm just going to call this value A. I'm just going to call this value B so that you understand, because there are so many things there. So you're going to have minus here A to the exponent of 3 minus 3, A to the exponent of 2 minus 2, A that we are given. This is your upper limit. You substitute that. Minus, you do the same thing. On the lower limit, you substitute this. So it was going to be minus. I'm just going to call it B. So this is B to the exponent of 3 minus 3 into B to the exponent of 2 minus 2 into that B. Guys, as we saw, there's but you're supposed to do that. So you see that part that I was explaining of storing a value on your calculator, then you recall it. There is gonna work because, guys, these values are to me, but it's exam, guys. You can even just substitute your values as they are. So do not confuse here, guys. I'm just saying where A is, it's minus 0.422 minus 0, so that we do not have a confusion. There will be many things that you're going to have. So I want you to simplify properly on your calculator. The first part, this one, was going to give you that was going to give you 0.385. Minus the second part, this one, when you substitute the minus 1, in place of B, it's minus this. In place of B, that's our minus. Why is this one repeating? Minus 1.577. You substitute that in place of B. That was going to give you a negative 0.385. So minus, minus, that's a plus. So the area was going to be obtained, which is 0.77, 0 to 3 decimal places. Remember, they say to 3 decimal places, just going to put a 0 there. This is area measured in what? Square units. That's like that. So they test you. They are going to test you this and that, guy. You have to be very, very careful in your simplification. All right. I need this part of our graph. So let me just not remove this so that we can have the other part. So considering area, guys, y1 minus y2, the one that is on top minus the one that is below, because remember, different textbook, guys, we are using. Another textbook will be writing y2 minus y1. But what they mean there is that it's top minus the bottom. That is what they will be meaning there. So no matter the simplification, you can still use that consideration to say you are working with one that is on what? On top minus the one below. With the same situation, they want you 5.32 to calculate the volume of the solid of revolution formed when the area in question 5.31 is rotated about the x-axis, according to the limits that you're given. So you need volume with respect to x. That's 5.32. So as you can see, this is just our normal disk method that we have to consider. And the volume pi, that is going to be y1 squared minus y2 squared with respect to x and our limits a and b. y1, as we had it before, the top part, the minus x as we had. So there's nothing that changed. That's same, but now it is just being squared. The limits also, nothing changed. Minus 1.577, minus 4.22. So y1 squared, you have to square that. Minus x squared, minus y2, the y2, this part as it is 3x squared plus 5x plus 2 as it is, you square it like that. So that is what you're going to have, whatever that you simplify from here, integrated with respect to x. So this is what you're going to have. As you can see here, we're going to have Vx is equal to pi integral of, so here I'm just going to be fast, guys. There's so many values there. Just to be patient as you are working on yourself. Minus x squared, that will be x squared. Negative when raised to the exponent of 2 becomes a positive. Minus, you're supposed to subtract whatever that you're going to obtain when you expand this bracket of 3x squared plus 5x plus 2. Meaning you say there's another bracket there, 3x squared plus 5x plus 2. So if you check your memo there, they just did a mistake on expanding, but it was nothing, guys. This one is to expand everything in this bracket. So it's 3, multiplying the 3 there, which is going to be 9x to the exponent of a 4. 3 and 5, that is 15x to the exponent of a 3. 3 and a 6, 3 and a 2, that will be a 6. That's 6x squared. We are done with the 3, move on to 5. So 5 also multiplies everything. 5 and 3, which was going to be 15x to the exponent of what? 3. 5 and a 5, that is going to be 25x squared. 5x and the 2 there, that was going to give us 10x. You move on to plus 2. Do the same thing. Plus 2 multiplies everything. So it's 2 and 3. 6x squared. 2 and 5 here, which is going to be 10x. 2 and 2 there, which is a 4. So considering the like terms, we can say that the 9x to the exponent of 4 is on its own. This one, it is on its own. But the part of x to the exponent of 3, we have it here, x to the exponent of 3, x to the exponent of 3. So you're going to add 15 plus 15, which is what? Which is 30. X to the exponent of 3. Then I consider this part of x squared. There's 6x squared here, 25x squared, 6x squared. So you're going to add, that is 12 plus this. We add 25 plus that 12 there, which is going to be 37. So that was going to be 37 there. 37x squared. Then the part of x, if you consider that, we have got 10x, 10x. So if you add this 10x and 10x was going to be 20x. So that's 20x plus the remaining term, which is 4. So on the memo, they just made a mistake on this one. It's supposed to be 37 there. They wanted to write just 37. So this is what you have, guys. You have to expand this way. And after expanding, it's supposed to be subtracted here, as we saw, that, guys, that is supposed to be subtracted. So I'm not going to do this way. I'm just going to take that. Remember, you're supposed to subtract it. So I'm just going to put a negative here because we're going to have a lot of stages here. So on this answer that we are having, we're going to subtract, put a negative there. This one that was here. So it's minus times this. So we're going to have minus 9x to the exponent of 4. Minus 30x to the exponent of 3, minus 37x squared, minus 20x minus 4, like that. This is what you're going to have. So you expand it, then you substitute there with a negative that is there for subtraction. So you're going to affect each and every term. By doing this, you are going to see that x squared and x squared can be simplified. This one and this one, these are like terms. The remaining is going to remain, it's going to be as it is there. Minus 1,577 minus 0,422 of what? This one, let's start with this highest power, followed by 3. Then the part of x squared. So this is 1 minus 37, which is minus 36 x squared. The part of 20, x, and the minus 4 as it is, like that. We can integrate each and every term with respect to x. We can integrate now. So that was going to be pi. Let's integrate this. Remember, add a 1. That was going to be 5 there. So it's minus 9x to the exponent of 5 over the new exponent, which is 5. You add a 1, that was going to be 4. So it was going to be minus 30x to the exponent of 4 over a 4, like this, which you can reduce On your calculator, it was going to be minus 15 over 2. So this was going to be minus 15x to the exponent of 4 over 2. We move on to this part of minus 36. We do the same, add a 1 there. So it's going to be 30. It's going to be a 3. Minus 36x to the exponent of 3 over a 3. Cancel this. That was going to be minus 12. All right. Then the 20x, you do the same. It's having a 1 already. So if you add a 1 there, that will be minus 20x squared over 2. Cancel this. That was going to be minus 10x squared. Minus 4 is a constant, so that will be minus 4x when integrated with respect to x. With our limits, as we are having this minus 0,422 and minus 1,577, you were going to obtain the volume by substituting as we had before. Upper limit minus lower limit. So guys, we saw what we had before. So for the sake of values, I'm going to write this as A, this one as B. So you're going to substitute on your calculator. It was going to be pi. This part you substitute minus A to the exponent. Guys, you're going to substitute upper limit minus lower limit here so that we do not waste much time there. So it was going to be upper minus the lower limit being substituted. So in place of the upper limit, this one, if you substitute there, the minus 0,422, if you substitute that properly, you're going to get 0,595. Minus, if you substitute the lower limit, this one of minus 1,577, you're going to get minus 0,329. This is what you're going to get. And we can simplify that on your calculator. This one is super plus. So that was going to give us 0,924 times the pi, which is outside. So this will give us 2,903 if you simplify on your calculator. This is volume cubic what? Cubic units in cubic units. So make sure you substitute properly the upper class minus, just like what we had on area, guys. We had this one. Just try to substitute properly. This is what you were going to have at the end. So you just have to be very, very careful. These questions, they do happen like that. Can be like that in other cases. Then on question number 4, considering the moment of inertia of a circular lamina of radius r over 2. So being given the radius of r over 2, it means our radius is being taken from the center, which is at 0 to what? To r over 2. Like these are the limits that you're given. And the mass about an axis and its center and perpendicular to the plane. So remember from the moment of inertia that if you are to consider the mass, it's actually the product of the area density times the area, which if you are given the area, and considering that this is a circular and our area of a circular is given a circle is 2 pi r. Remember the area of a circle, 2 pi r. 2 pi times r. So meaning to say we consider the area density, not the volume, but area density in that case. So area, consider of a circle. So we're going to calculate our moment of inertia, guys, from 2 pi, the area density, times the area now, but the area has to be considered in terms of the integral. That was going to be x. Remember our limits. Now the radius there. So you're going to have radius times the integral. It was supposed to be r dm, this one. So this radius is actually inside of the integral. Why am I writing this outside, guys? It's like radius times radius squared. So it will give you radius cubed, where the radius is just presenting x values on that consideration. So this will be x to the exponent of 3 with respect to x. Our limits from 0 to r over 2. So this topic, guys, I think, N6, that is where you learn properly this topic. N5, just try to work out question papers. Even I was seeing the new syllabus textbooks, they even, like, the way they explain there is actually something else. But if you're N6, of which we're not going to talk about those in N5, about N6. So yeah, that's it, guys. Let's integrate. With respect to x, we're going to have 2 pi, the area density, This is just raise 1, add 1 here. That's x to the exponent of 4 over 4. Our limits are over 2 to 0 there. So that's 2 pi times the area density. You substitute upper limit minus lower limit, just like what we had. So it's r over 2 to the power of 4 over what? Over 4. So it was going to be r to the power of 4 over what? 2 to the exponent of 4 is 16, but you're dividing by 4. So it's simply multiply 16 times 4. So it will be r to the exponent of 4 over 16 times 4, which is 64. Minus the lower limit you put there as 0 there. So it was just going to be a 0. So this is it, guys. You've integrated, substitute your limit in terms of what? In terms of the radius. So this can be written as r cubed over what? Over 64 as we have it here. In terms of the area density, which you can also substitute back in terms of what? In terms of the mass, because mass from this one, mass times area, and our area is 2 pi r. So it means area density times 2 pi r. If we can have, where am I getting? Area pi, guys, pi r squared. I'm talking about the area, pi r squared, area that you consider of a circle, pi r squared. That derivative, the derivative, the 2 pi r h, which we're gonna convert, but we need area, this one. So if you're to remove that, you can actually remove that in terms of the mass and say this mass here, since it is equal to area density times, it's supposed to be pi r squared like that. Area density times area, and area is pi r squared. So you can remove this and put back the mass that we had if we want to do that. So can we have pi r squared from this? This is, guys, yeah, I'm having a lot of, now my mind is tired. I can even feel it. This is to the exponent of 4 here, guys, remember? So what is that I want you to do is to remove this one, and replace with m. So how can we remove it? We can see the pi is there, the area density is there. So this radius is supposed to be written as r squared. So to write it in terms of r squared, we're going to have it this way. So it's going to be 2 pi area density r squared times r squared over 16. There's no effect there. R squared times r squared is still r to the power of 4. As we just need this part here, pi, this one, the pi r squared, this one, pi r squared, this one, pi r squared, and the area density. It replaces what? It is replaced with the mass. So you can even replace that one with the mass. The 2 and the 64. Yeah, the 2 and the 64 can also reduce 2 into 2. That's 1 into 64. That's 32. So this will give us what at the end? Remember, I said this, we have removed it in terms of the mass. So it's mass r squared over 32. You can even write your answer like this. Okay, so that is how it can be like. That's how it can be like. So guys, let me just pause a little bit so that I can finish the other question that we are having here. Let me just pause a little bit because the way my mind is tired, I'm just going to explain something else. So just 2 seconds. All right. So if you're to consider question 6, we had a condition there, determine the particular solution of this derivative with respect to x that we are given. So that's we're given divide x is equal to, that's 2xy like this over y squared minus 1. And you are given a condition y2 is equal to 1. They're giving you the x value there. When you substitute the value of x to be 2, the y is supposed to be what? The y value is supposed to be 1. So this is where you now have the particular solution. But let's have the general solution first on this. By separation, as you can see, you've got x and y. You can just try to separate our terms. The part of x with the dx, the part of y with dy. How easy can we make this? Okay, let's try to cross multiply that is going to be y squared minus 1 as it is times dy is equal to the dx multiplies this part of 2xy like this. That's dx. So we can see we still have y on the side of x. So this is not supposed to be like that. So just divide by that y like this. So this type of equation, it was at least easier to work with. Then on this side of our left-hand side, we can try to separate, as we know y squared minus 1 over y is same as y squared over y minus 1 over y like that. So you can even cancel this. That's going to give us the value of y there minus 1 over y, of which y 1 over y is same as y to the exponent of -1, or you can just leave it as 1 because you are doing the derivative there. So just leave it as 1 over y, because if you use a negative there, it is going to affect you as you are to differentiate. Remember your derivatives. You cannot differentiate. I remember the integrals. When you have got 1 over y like this, you can easily integrate the part of what? Of 1 over y than to work with the y of -1. To integrate that is going to be difficult. So work with 1 over y instead. So to obtain this, integrate both sides so that you now remove this integral because we are integrating with respect to y. So meaning say we can integrate these guys. Adding a 1, it's already a 1 here, so add a 1, that will be y squared over the new exponent minus the integral of 1 over y with respect to y is what? That's a ln, which is equal to, you integrate that x, it's already 1. So if we add a 1, that was going to be 2x squared over 2, the new exponent. And that was going to cancel. We have got x squared plus the constant of integration. This is our general solution, but they do not want us to determine the general solution. They want you to have the particular solution. That is where these values now play a role. Substitution of these. Where x is, you put a 2. Where y is, you're going to put a 1 and calculate the value of c. So we saw that y is 1, so 1 squared over 2 minus the ln of 1 is equal to x was a 2. So that's 2 squared plus c. Knowing that the ln of y is what? That's a 0, this one. So you're going to get 1 over 2, 2 squared, which is 4 plus c. Then you can even take the 4 to the other side. So that's 1 over 2 minus a 4, which was going to give us -7 over 2, giving us the value of what? Of c. So determining the value of c allows us to say this whole equation, therefore, can be written as y squared over 2 minus the ln of y is equal to the right-hand side as it is x squared plus c plus this. So it's going to be -7 over 2. So we can have it that way. We can actually have it that way. You're done. Particular solution is the one that you are being asked there. So these are the stages that you can actually take. Separating, try by all means to separate the given question that you have, which is different when you've got the highest power of 2 like that. And on this question, it was just a mistake here. This was supposed to be 14x, okay? They just made a mistake. It was supposed to be 14x plus 2x, okay? Into, this was second derivative is equal to 2x cubed minus 6x squared. So we can even transpose this because we need to separate and remain with this one. We have to make this the subject. So this term has nothing to do with that. So let's take it to the other side. It becomes a negative there. So it was going to be 2x second derivative of y with respect to x. The right-hand side, 2x cubed minus 6x squared. Take the 14x this side. So it will be a negative there, -14x. We still need this. So what is affecting this time? A product there of 2x and a product. So you can simply remove this by dividing each and every term by the 2x that we are seeing, each and every term that we are having. So this can cancel. And we have what? Second derivative of y with respect to x. So what we're going to have on this part, the 2 and 2 cancel, x into this, that was going to be x squared. All right, the 2 and the 3 there, the 6 is going to be minus 3, x into x squared, which was going to be x. So it was going to be x there. Then on this one, x and x was going to cancel, and this was going to be a minus 7. So I want us to correct that part. Was supposed to be 14x there. And by integrables, we need to determine y at the end, and they want the general solution like this one. We do not have any values to be substituted. So by integrating this with respect to, this is we're going to put in your mind that you are integrating this with respect to x. So integrating is simply finding or determining dy dx. The power reduces. But this side, integrate as usual, raise your powers as we had, guys. Gonna add 1 there. To the exponent of 3 over 3, you add 1. This is 1 plus 1, which is 2. So that's minus 3x squared over 2. The minus 7 will give us minus 7x plus the constant of integration. It's going to call a, because we need to integrate again. So we have that as a, b, c, and so on and so on. Integrating this with respect to x, also integrating this with respect to x will give us the value of y from dy dx squared. Dy dx, now it will be y. You integrate just like the previous case that you had. Remember, integrating the issue of the exponents there, add 1, x to the exponent of 4 over the new power, but already there is a 3 which is there. So it was going to be 4 times 3, which is 12. So that's x to the exponent of 4 over 12. Minus, you do the same thing on this 3x to the exponent of 2. You're going to add a 1 there, which was going to be minus 3x cubed over the new exponent, which is 3. But already there is a exponent, which was already, the denominator, which was 2. So this was going to cancel, and you remain with what? Minus x cubed over 2. Same thing on this minus 7x that you have. It's a 1 on its own. So 1 plus 1, that's what? 2. Minus 7x squared over the new exponent, which is 2. A is a constant. With respect to x, it is going to be ax. We have integrated that. Everything has been integrated. So don't forget another constant now, which is b. So with this, we have got the general solution, which we cannot determine the value of a or the value of b because we are not given any corresponding information on this one. So this is how our questions, guys, are supposed to be like. Let us just try to revise as many questions as we can in our exams. We need preparation in order for us to face our exams. We need much preparation. So do so by working out as many question papers. Like I said, on the comment section, you can even talk about that, the areas that we can add as we are moving on with our revision. So that was it, guys, out of 100. So I just hope under exam condition, we are going to score this. Let it be so. So that is it, guys. Till we meet again.